This video will deal with the electrolysis of copper 2 chloride. Let's start by considering what copper 2 chloride is. It's the electrolyte that we're going to be using, and as the formula suggests, it is an electrolyte. It's a solution of an ionic compound that contains copper 2 plus ions. The 2 given in the copper 2 chloride formula, that 2 refers to copper's oxidation number, and obviously links to its charge, to the charge of the ion. So the copper has a 2 plus charge. So if you imagine an ordinary copper atom, for it to become charged with a 2 plus charge, it needs to lose 2 electrons. And so you can imagine that those 2 little holes there represent the 2 electrons that have been lost to form the copper 2 plus ion. The negative ion, the anion, is the chloride ion, a Cl minus ion. And again, if you imagine a chlorine atom being represented by that black sphere, then a Cl minus ion means that the chlorine atom has gained an electron, and there's the little red dot to illustrate the electron. And that extra electron gives it a full outer shell. It now has 8 electrons in its outer shell, and with that full octet becomes stable. So our copper 2 plus, our copper chloride electrolyte contains Cu2 plus ions and Cl minus ions. So to set up the electrolysis experiment, we would take a beaker and fill it with copper chloride solution. It's a pale blue color. The copper 2 plus ion is responsible for that color. We then put 2 graphite electrodes into that solution. Graphite's used because it's a good conductor, and we'd then connect that via 2 wires to a power supply. We're using a single cell here in this diagram. Remember, the long end of the cell indicates the positive side of the cell, and the short end the negative side. And so electrons would flow around into the positive end of the battery, and obviously out on the negative end and around, which would mean that the electrode on the left would have a deficiency of electrons and therefore would be positively charged, and the electrode on the right would have an excess of electrons and therefore be negatively charged. If we now consider our electrolyte, remember it's copper 2 chloride, so we have Cu2 plus ions and Cl minus ions in solution. And the electrostatic force of attraction between opposite charges will mean that our Cu2 plus ions are attracted across to the negative electrode, and obviously our Cl minus ions would be attracted to the positive electrode. We're going to consider each electrode in turn. Let's start with the positive electrode. We said that our Cl minus ions would be attracted to that electrode because they're negatively charged, so they're attracted to the positive electrode. And remember, the Cl minus ions each have a single extra electron, and that electron would be attracted to the positive electrode, and due to the electrostatic attraction, the electrons would be stripped off the chloride ions onto the positive electrode, leaving individual chlorine atoms. Those electrons then would travel up the electrode and up towards the battery. So the half reaction then for this little reaction taking place is that 2 Cl minus ions lose their electrons, and they go to form Cl2 plus those 2 electrons that they've lost. Chlorine doesn't exist as monatomic atoms because they have only 7 electrons in the outer shell, so they will always bond to another chlorine atom to form a diatomic molecule, Cl2. Now, this process of losing electrons is called oxidation. Oxidation is defined as the loss of electrons, and you can clearly see that those chloride ions are losing electrons. So this is oxidation, and the electrode at which oxidation takes place is defined as the anode. So in this electrolytic cell, the positive electrode is the anode, and you remember the acronym oil rig. Oil standing for oxidation is loss, and it can be helpful to remember oil rig. Oxidation is loss, and then the A stands for anode. So oxidation is loss at the anode. The two Cl atoms join together as a Cl2 molecule, and that's of course elemental chlorine. And so what we're forming at the positive electrode is chlorine gas, which will be released from the electrolytic cell. Let's now consider the negative electrode. That would obviously attract the Cu2 plus ion. The positive ion is attracted to the negative electrode. Now, the negative electrode contains an excess of electrons. I've just indicated 2 of them there. There'd obviously be many of them on that electrode. And the Cu2 plus attracts those 2 electrons, and those electrons then would fill the spaces that were created when the 2 plus ion was originally created. And those electrons would go and join the Cu2 plus ion, and that would form a copper atom, a Cu atom. So our half reaction then is Cu2 plus gaining those 2 electrons to form copper. And you'll remember that reduction is defined as the gain of electrons. So you can clearly see that the Cu2 plus ion is being reduced because it's gaining electrons. The cathode is defined as the electrode at which reduction takes place. So the negative electrode would be the cathode. And over time, we would have more and more of these copper atoms being formed at the electrode, and slowly that electrode would become copper plated. If we have a look at the overall reaction then, the anode half reaction is the oxidation reaction where the chloride ions form chlorine gas. The cathode reaction is the reaction where copper 2 plus gains 2 electrons. And to work out the overall reaction, the first thing we do is to equate the electrons. And in this particular case, you'll notice that there are 2 electrons on either side. So there's no need for us to introduce any more balancing numbers. They simply cancel out. And we then add everything on the left and everything on the right of the reaction arrow. And so our overall reaction is 2Cl minus plus Cu2 plus, giving us the Cl2 chlorine gas that would be released, and Cu, the copper that would plate the electrodes. If we go back to our cell, as we run this cell, our positive electrode, where oxidation takes place, we would see bubbles of chlorine gas possibly being formed, and that chlorine gas would be released. And if you smell that area of the electrolysis cell, you'll smell the distinctive smell of chlorine gas that you might have smelt around swimming pools that use chlorine with the water. At the negative electrode, where a reduction is taking place, copper would be formed, and that copper would slowly plate the electrode, and you'd see that very distinctive browny orangey color of copper being formed. So that's the process that takes place during the electrolysis of copper chloride.